Welcome to Lesson 3, where we're going to learn about selection structures. Selection structures is a long way of saying if-else statements and teaching a computer to make decisions. I know you've always wished that your computer could make better decisions. Now you have the power to teach it how to do that. For selection structures, we're going to be learning how to control our programs using if statements, if-else statements, nested if-else statements, and Boolean logic. So let's start with the if-else. The if-else is, in Scratch, the C block or the E block, right? Remember these two where you could have a true-false statement and you would put a command block inside of this C, and then this code only runs if the condition is true. Well, the same thing exists in Python. You can have an if statement, the condition comes right after it, so it's the word if, lowercase, then a colon, and then the body of the if statement is going to be code that is on the next line with an indent. You can have multiple lines here if you want to have multiple lines inside of the body here, but they all need to be indented over, right? The indent is basically telling us what's inside of the C. An if-else statement is going to look very similar. You have the word if, your condition, a colon, and then you have this line of code indented over. But then the important thing is that the else has to be back on the same line as the if. This is how the computer, when it reads this code, it knows, okay, this else is not part of the code inside the if statement. It's actually its own structure. And then we have a colon that says, okay, the code after this is only going to run if this statement is false. You have the same structure in AP pseudocode. It just looks slightly different. In AP pseudocode, if is capitalized, your condition is in parentheses, and you have these curly braces that tell you what's inside the body. Same deal with the if-else. So what if things start to get a little more complicated? Let's say you wanted to build a nested if statement, right? Nested if statements allow you to control a program and to use logic that is much more complex. In Scratch, this got really messy, right? Remember, you had if-elses inside of if-elses, inside of if-elses, inside of if-elses. And this is a program that would read in someone's score and then tell you what grade they got, right? That's what this would look like in Scratch. Well, in Python, we have a keyword that allows us to build these nested if statements without having to increase indentation, which is really nice. So the way you do this is you have your if statement and your condition, and then underneath it, instead of saying else, you use the word elif. Basically, this is shorthand for else if grade is greater than 79, then print you got a B. Else if grade is greater than 69, print you got a C. Else if grade is greater than 64, print you got a D. And then finally, you have to have an else here at the end to indicate that this is over, that this chain, you're no longer including an if statement for this one, right? I mean, you could have just ended with this statement, but by using the word else instead of else if, you indicate that you're not going to put a condition here, and this is going to be the last statement. Okay, in AP pseudocode, again, we don't have this handy elif. Instead, we have to put nested if statements inside of else statements, and it gets really messy. I prefer Python. Maybe you do too. So we also need to have logical operators, right? So we can build more complex conditions, because it's not always just going to be one simple, is x greater than 16? That's not going to be the case with some of our more complicated programs. So in Scratch, you had these diamond-shaped blocks that had an and, the word and you could put multiple conditions inside of here. And, or, and not. These are the three important logical operators you need to build complex Boolean statements or complex conditions. In Python, we have the same thing, but it's just the word and, or, and not in lowercase. And then you would put the operators either on the left and the right side, or with not, you would put it right after the word not. Same thing in AP pseudocode. So what about relational operators? Relational operators are like the comparators. This is how we would compare two values. And remember, in Scratch, they're going to be those diamonds where you have greater than, less than, equal to. Here you see an or statement comparing two things. This is how you would do greater than or equal to, less than or equal to, or a not. In Python, we can do those with compound operators, which we'll look at right here. Most of these operators are going to be the same. You have the caret, the other caret going the other direction. This is an important one. If you're checking if two things are equal in Python, you need to use two equal signs. Okay? That's because the one equal sign is the assignment operator, which is different, And it's a common mistake that I've made many times myself, where if you use a single equal sign, that means we're saving the number 0 into the variable x. Two equal signs means that we're checking if these two are equivalent values. So greater than or equal to, you can combine these two operators like this, less than or equal to, and then this exclamation point in Python, that means not. So it basically is saying here if x is not equal to 0. In AP pseudocode, you also have the same operators, but because it's not a coded language, you have some special characters here that make things a little bit easier. All right, we're going to learn in today's exercises how to use these operators and combine them to create complex Boolean statements and complex if-else programs. But before you do that, there's another thing in Python which makes Python sort of easier to extend. In Scratch, most of the blocks that you need come built in. But in Python, there are lots of different functions that you might want that don't come standard. Instead, you need to include them in something called a module. Okay, so modules are basically like libraries that give you lots of useful methods, lots of useful functions. These are functions that some other programmer wrote these for you, and now you can just use them in your program. It's great. It basically is someone else did the hard work for you, and you can build on their work. The reason you do this is because someday you're going to be a programmer and you're going to write some really awesome functions and you're going to want to share them with the world. And I hope that you will provide them as a module so that other programmers can build on your work to continue to create awesome programs.